Welcome to the NIME workflow named Data Tree. This workflow uses the customer scores database without missing data to illustrate different sampling techniques. The workflow starts by first loading the customer scores database and in particular by loading the customer scores database without missing data. Then we use the sorter node, where the sorter node can be found under the section Data Manipulation, Row and Transform, to show which is the effect of a non-random allocation of records into the dataset on some of the sampling techniques we are going to present here. In particular, we make the decision to sort in ascending order the records of the dataset with respect to the cast-served calls attribute. Then we move to the sampling task that we want to discuss here. NIME offers from this point of view different options. The first one that we take into account is offered by the node partitioning. The node partitioning can be found in the section Data Manipulation, Row and Transform. This node receives in input one dataset and provides two different partitions, the first partition and the second partition. These two partitions are mutually exclusive. To set up the partitioning node, we right-click the button of the mouse and we access the Configure option by opening this window. In this window we can identify two different sections, the upper section and the lower section. In the upper section we have two different alternatives. They are absolute and relative percentage. If absolute is selected, then we specify the absolute number of rows in the first partition. And if there are less rows than specified here, all rows are entered into the first partition, while the second partition contains no rows, no records. In our case, if we let this setting, then the 100 of records of the customer score database will be included into the first partition, while the remaining one will be included into the second partition. If we select the relative percentage, then the percentage of the number of rows in the input table that are in the first partition is fixed. In our case, we are setting up that 10% of the records of the original dataset will be included into the first partition, while the remaining 90% will be included into the second partition. In the second section of the partitioning window, we can specify which type of sampling techniques we want to use. Four options are available here. We have the take from top, the linear sampling, the draw randomly, and the stratified sampling. The take from top is such that the topmost rows into the first output table are included, while the remainder are included into the second partition. The linear sampling option is such that it always includes the first and the last row of the dataset and select the remaining rows linearly over the whole table. This is an option which is useful to downsample a sorted column while maintaining minimum and maximum values. Then we have the draw randomly option, and this is the typical random sampling option. In particular, we select with a random fashion the records from the dataset. Under this option, we can also select the random seed to be used. The possibility to select a given random seed, it is particularly useful when we want to obtain a workflow where the results are reproducible. We have finally the stratified sampling technique, which is associated with the specific attribute that has to be used for the stratification. In our case, we select the churn attribute, so the output attributes. In particular, stratified sampling is such that if you check this button, you want stratified sampling to be applied. So the distribution of the values in the selected column, in churn in our case, is approximately retained in the output table, so in the first and in the second partition. Also, for the stratified sampling, we can make the decision to use a specific random seed. Once we have selected all the options of the partitioning node, we move to the column filter node. This node is used to focus our attention only on two attributes, which are day means and churn. In particular, they have been selected because they are one quantitative and one qualitative, and we will use them to check the quality, the particular reliability or representativeness of the sample that can be obtained with different sampling techniques. Then we use a statistics node to compute the summary statistics for the two attributes that have been filtered with the column filter. This information flow, moving from the take from the top, from the partition to the column filter to the statistics, is reproduced several times by simply changing the type of the sampling techniques to be used. In particular, here we use the take from the top, here we use the linear sampling, then we use here the random sampling, and we do not use the random seed. Then we select the stratified sampling. Finally, we also use the whole dataset, so we compute the summary statistics again for the churn and for the day means attributes using the whole dataset. Then these two meta nodes are used to concatenate the results for the day means and for the churn attributes to make a comparison about the properties of the samples, of the different sampling techniques, so of the sample obtained using different sampling techniques, and the property of the original dataset. We start by focusing our attention to the qualitative attribute churn, and to inspect what we have obtained with different sampling techniques, we use the interactive table that allows us to evaluate which is the percentage of values n for the output attribute, so for the churn attribute. We have that the dataset contains 0.855 of the record having value n, so around 85.5% of the records have the value n. For the stratified sampling, we obtain a sample that has a percentage equal to 85.6%, so it is quite close to the whole dataset percentage. Also, using draw random sampling, we achieve 83.5%. If we use linear sampling, we have 87.1%. While if we use take from the top, we obtain quite a different percentage. We obtain 90.1%, which is quite far from the percentage of the whole dataset. So we can conclude that the sample that we have obtained using the take from top is not representative. So at least it is less representative than the sample that have been obtained using linear sampling, draw randomly, and stratified sampling. We also have a different possibility to show this picture using the box plot. And from this box plot, it is quite evident that the take from top achieves a value which is very far away from the one associated with the whole dataset. while linear sampling, draw randomly, and stratified sampling achieve values which are not that far, with stratified sampling being the one that perform better or perform best than the others. Then we can focus the attention to the day means attribute, and in this case we use again the interactive table node, and we can access the output of the computation of interactive table node as follows. So selecting this option. Here we have different sampling techniques. We have take from top, linear sampling, draw randomly, and stratified sampling. And we also have what is obtained on the whole data set. In particular, the value of the mean and of the max of the samples are reported. We also have the value of the mean, of the standard deviation, the variance, higher order moments as skewness or kurtosis, and we also have the information related to the median. And finally, we have the histogram, the representation of the histograms. We can see here that the row count for each of the samples is the same. We always form a sample consisting of 333 records, while the dataset consists of 3,333 records. So we can now close this window, and we can focus the attention to the shuffle node. Indeed, we concluded that the take from top sampling scheme is extremely sensitive to the fact that the records of the customer scores database are not randomly allocated. If we suspect that some specific order is imposed into the dataset that we have to sample, we can use the shuffle node. The shuffle node can be found under the section data manipulation, row and transform, and we add this node to our workflow. Then we connect this node with the sorter node, and then we connect the shuffle node. We connect the output port of the shuffle node with the input port of take from the top, of linear sampling, of draw randomly, of stratified sampling. Then we can set up the shuffle node, selecting the configure, and the only option we have is to select the seed, but in this case we use the default, and so we do not specify any seed. Then executing the workflow and analyzing the result, this is what we obtain. We focus first the attention to the interactive table churn, and in this case we can see that the take from top achieves a value which is not that different from the dataset percentage, so the take from the top improved, and the other methods more or less behaves the same. Also, the same consideration applies to the day means. KNIME offers more nodes to implement sampling techniques. The first one that we present here is the equal size sampling node. The equal size sampling node can be found in the section Data Manipulation, Row and Transform. This node allows to perform equal size sampling. In other words, it removes rows from the input dataset, from the customer scores dataset, in such a way that the values in a categorical column are equally distributed. This can be useful, for instance, if a learning algorithm or a learning model is prone to unequal class distributions and you want to downsize the dataset so that the class attributes occur equally often in the dataset. To set up the equal size sampling node, we right-click the bottom of the mouse and we select the configure option. Then the following window opens and we can select which is the nominal column to be used for the equal size sampling. In our case, the class attribute is churn, and so we want to obtain a sample where we have exactly the same number of records, where churn is equal to n and where churn is equal to y. In this area we can select through these two radio buttons whether to use exact sampling or approximate sampling. It is worthwhile to mention that when the dataset is contains an extremely high number of records, or the nominal column can take many values, then exact sampling can become too computationally demanding, and so we have to resort to the approximate sampling. However, this is not the case of the customer scores database, and so we will use exact sampling. Once we have executed the equal size sampling node, we can access the output of its execution by using the downsample input option. However, in this case, we will use the bar chart node, where the bar chart node can be found under the section Data Views JFree Chart. With these two instances of the bar chart, we inspect which is the distribution of the chart attribute on the sample obtained using the equal size sampling and on the whole dataset, so on the whole customer code database. The frequency that we have on the whole dataset is represented by this histogram. Here we have the number of records where the attribute churn is equal to n. Here we have the number of records where the churn attribute is equal to y. Then we can access the output of the bar chart in the case of the sample obtained with the equal size sampling, and it is clear that we have the same number of records where the churn attribute is equal to n and where the churn attribute is equal to y. Now we can move to the second additional option offered by NIME for random sampling techniques. This is the bootstrap sampling node, and to show how this bootstrap sampling node can be found, we use this search tool and we end up with the data manipulation row and transform section. This node is such that it samples the data using bootstrapping. Bootstrapping is a sampling technique which randomly draws rows from the input dataset from the customer scores database with replacement. The output table will therefore likely contain duplicate rows, while other rows are not present in the output at all. So to configure this node, again we right-click the button and we select the configure option. In this case we can make the choice about which is the dimension of the sample to be generated, and in this case we can select a given percentage of the original dataset, or we can specify a given absolute value, so the absolute sample size. We can also make the decision whether to use a random seed or not. Again, this is useful when we want to have reproducible results. And we also make the decision to append the count of occurrences for each observation, and eventually also append the original row ID to increase the capability to recognize duplicate records that have been sampled. Okay, so now we can close this window, and once we have executed the bootstrap sampling, we have two different output ports. In the first output port we have the bootstrap sample, while in the other output port we have the hold out sample. Also, in this case, we use the bar chart node to analyze which is the output of the bootstrap sampling execution. And we compare again the partitioning that we obtain on the overall dataset and on the sample that has been obtained through bootstrap sampling. The overall dataset has been already shown before, so we just focus on the distribution concerning the sample that we have obtained, and this is the distribution of the counts that we have for the sample which has been obtained with bootstrap sampling with replacement. It is worthwhile to mention that we can access the output of the bootstrap sampling also selecting the bootstrap samples option. In this case, this table opens and we can clearly check which records have been selected more than once. Here we have the column count of occurrences that we have made the decision to add when configuring the bootstrap sampling node, and here we can see that the first row is selected just one, the same apply up to here, while this node, so the row 482, is selected 2 times, and indeed we have that it has been selected here and here. So it is clear from the inspection of this dataset that some records are selected more than once, which is the typical characteristics of the random sampling with replacement.